Have you ever wondered why hitting a pothole in one car feels like a minor bump, but in another it feels like the whole car is about to fall apart? Well, today we're diving into the suspension system. It's the unsung hero of your car, and it's constantly waging this hidden war between a smooth, comfortable ride and razor-sharp handling.
I mean, think about it. Why is the difference so huge? A race car or a hardcore sports car is so stiff you can feel every single crack in the pavement. But then you get into a big family sedan and it just seems to float over everything. It's not magic, not at all. It's a very, very deliberate choice made by engineers. And that choice is really the heart of our entire explainer today. You see, every single car out there is basically a compromise, a trade-off between making the ride comfortable for you, the passenger, and making the car controllable for you, the driver.
Okay, so let's get right into it. We're calling this the Great Balancing Act for a reason. Engineers are basically trying to serve two masters, and those two masters almost never agree on anything. So on one side of the scale, you have ride comfort. The goal here is simple. Isolate you and the car's body from all the bumps, the vibrations, everything the road throws at you. But on the other side, you've got handling. This is all about keeping the tires glued to the road, maintaining maximum grip at all times. And here's the fundamental problem. A soft, cushiony suspension that's great for comfort is usually pretty terrible for handling. And a stiff, rigid suspension that gives you amazing handling, well, you're going to feel every single pebble on the road. So, how in the world do they manage this balancing act? Well, they've got three main tools in their toolkit. First, you've got springs. Their job is to absorb that initial impact from a bump. Then you have dampers. You probably know them as shock absorbers. Their job is to control the spring and stop it from just bouncing and bouncing forever. And finally, you have linkages. These are all the arms and rods that physically connect the wheel to the car and dictate exactly how it moves. The real magic is in how an engineer chooses to combine and tune these three parts. All right, let's talk about the first huge design choice an engineer has to make. It's a big one, and it comes down to a simple question. Are the two wheels on an axle going to be linked together, or are they going to go it alone?
First up, we've got the old school approach, a dependent suspension. The easiest way to picture this is to imagine your left and right ankles are connected by a solid steel bar. Now, if your left foot steps on a rock, what happens? Your right foot gets yanked up along with it, right? That's exactly how this works. It's super simple and really strong, which is why you still find it on heavy-duty trucks. But for a comfortable ride or high-speed cornering, not so great.
Now compare that to an independent suspension. Here, each wheel is basically its own free agent. It can move up and down without affecting the wheel on the other side at all. A bump under the left tire has zero effect on the right. This is a massive, massive improvement for both comfort and for keeping that tire pressed firmly onto the road. And it's exactly why pretty much every single modern passenger car uses some form of this design.
So, since we're all basically driving cars with independent suspension, let's take a look at the two most common designs you're likely to find on the road right now, maybe even in your own car. On the left, you've got the McPherson strut. It's the workhorse of the car world, it's simple, it's cheap to make, and it doesn't take up much space. But on the right, you have the double wishbone setup. Now this one is more complex, has more parts, and it's more expensive. So why use it? Because it offers way better control over the angle of the wheel as it moves up and down. That's why you almost always find it on high-performance sports cars and high-end luxury cars, where that precise control is absolutely critical. And we're about to see just why that's so important. To really understand why that control is such a game changer, we got to do a quick little dive into the physics of what's actually happening down at the wheels. Let me introduce you to the number one enemy of every suspension engineer, unsprung mass. This is the weight of everything the springs don't hold up. So we're talking about your wheels, your tires, your brakes, anything that moves up and down with the road. The best way to think about it is trying to run with really heavy, clunky boots on. It's just harder to react quickly, right? That's the challenge for a suspension. So the rule here is incredibly simple. Lighter is always, always better. The less unsprung mass you have, the faster the wheel can react and follow every little contour of the road, and the effect is huge. There's a rule of thumb in car engineering that getting rid of 1 pound of unsprung mass feels like taking 4 pounds out of the main body of the car. It just improves everything. The tire stays in contact with the road for more grip, and less of that harshness gets sent up into the cabin for you to feel. Now, you might be wondering, how can a tiny little adjustment to the angle of the wheel make such a massive difference? Well, it all comes down to something called negative camber. See, when a car goes into a hard corner, the whole body wants to roll to the outside. This rolling motion tries to lift the inside edge of your outside tire right off the pavement. But if you pre-tilt the wheel inward like this, then as the car rolls, the tire actually flattens out perfectly against the road, maximizing the patch of rubber that's touching the ground. More rubber on the road means way more grip. And that is what that expensive double wishbone suspension is so darn good at controlling. So all of this brings us right back to where we started, this constant compromise. For nearly 100 years, engineers have been stuck with it. But what if they didn't have to be?
This has always been the deal, right? You had to pick your poison. Do you want a stiff, bone-jarring ride so you can have incredible handling? Or do you want a soft, comfortable ride that kind of feels like you're driving a boat through the corners?
That's been the choice for decades. Unless, that is, the suspension can start to think for itself. And that brings us to the world of active and semi-active suspensions. These amazing systems use a whole bunch of sensors to read the road surface, your speed, your steering hundreds of times every second. And based on that data, they can change the stiffness of the dampers almost instantly. So they can be soft and comfortable when you're just cruising on a bumpy highway, and then bam, they can firm up in a millisecond the second you turn into a corner. The ultimate goal here, the absolute holy grail of suspension design, is to finally have the best of both worlds. We're talking about getting the sharp, precise handling of a dedicated sports car when you want to have some fun, and the quiet, smooth, isolated ride of a luxury sedan when you just want to relax, all in the very same car.
So, it really leaves us with this fascinating question, doesn't it? As this technology gets faster, smarter, and eventually cheaper, are we finally on the verge of solving this century-old problem? Is the perfect ride, one that is both supremely comfortable and incredibly agile, finally within our reach?